Hi all. So welcome back to another session. So in the previous session we discussed about overloading concept in Java. So in this session we'll be discussing about method overriding. Okay. So let's quickly refer to a doc. So what is overriding? So overriding means just we are replacing our functionality with the inherited functionality. In the sense, let's say the definition is something like whatever method parent has by default available to the child through inheritance. As we know that inherit by using extends keyword we can inherit the properties of parent class. Okay, so if child class is not satisfied with the parent class implementation, then child class in Java is allowed to redefine the method based on their requirement, and this is nothing but overriding of methods. Basically this is overriding. So parent class method which is overridden that is with which is overridden is called the overridden method, and the child class method which is overriding is called the overriding method. Okay, simple example, let's see. Let's say we have class parent with public void property as the method. So parent has cash, land and gold as the assets they have in the property method. Okay, so void marry method, they have marry method has that parent is referring that Seema is the person that you will be allowed to marry. Okay, that is what parents implementation is. That, let's say, okay, let's say this is class C extends P, so child is extending parent. Okay, so here we the child defines whole its own implementation. That is, he wants to marry this whatever it is. What is Tanya or Soumya is the girl that the child wants to marry. Okay, so what is the concept here? How should we see that marry method is being overwritten by the child? Okay, so child does not want the parent implementation here. So child is does not, let's say that we can give an example of that. This is the case of, let's say, an arranged marriage, and this is the case of an love marriage. Okay, so we can say in simple as that child is not happy with the implementation of parent, so he is overriding his method and he is giving his own implementation that I want to marry so and so person. So this is the simple or real time example that we can look onto this overriding. Okay, so let's move further. Let's say so we have this class test. So we have the main method parent p is equal to new parent reference and parent runtime object. So p dot marry method if I call, so what will be the output? It will be parent method will be executed. Then child c is equal to new child. So this is what that parent child reference and child object. So once we are calling marry method, child execution will be there. Let's say parent method and child object. Okay, so p dot marry method if you call, that will be child implementation. Why? Because in overriding method resolution takes care by JVM, not by compiler. So which is based on runtime object. So these are the runtime objects. That is new p is this is the runtime object here. This is the runtime object here, and this is the runtime object here. Okay, we studied also now parent reference can be used to hold child object, child object, but by using that reference we can only call method available in the parents. Okay, so we are calling this method. So since this method is, it will check that C is there in first of all C is there, Mary is there in C. Yes, it's there in C, and if it's there in C, is it overridden? Yeah, this is overridden. So this will now the runtime object is what, the child method only. So if there is no marry method in the child implementation, then only we'll get this parent implementation. Otherwise, if that is overridden, so we'll get the child implementation. So that is what the next point says, that in overriding method resolution always takes care by JVM based on runtime object, and hence overriding is also considered as runtime polymorphism. That is, it's sorry, that is runtime object plays the important role here. Okay, so everything is output is based on runtime object or dynamic polymorphism or late binding. Okay, and since in overloading what is there, it is based on it is taken care by compiler based on reference type. That is why it is known as early binding or static polymorphism. Okay, sorry. So let's see the rules of overriding. Okay, In overriding, method names and argument types must be matched. That is, method signature must be matched. Okay, method name and argument types. That is what method signature means. Method name and argument types. Since there are no, so what is the method name here? It's only Mary. Okay, with no arguments here since. So this is the first rule. Okay, in overriding, return types must be same, but this is valid up to 1.4 version. From 1.5 version, we can change the return types. That is, point here is that if this is void, then when you are overriding this method, it should also be void in only. But this is only applicable till Java 1.4 version. From 1.5 version, it has been changed. You can do with respect to covariant return types. So let's see what it's written. In overriding, return type must be same, but this rule is applicable until 1.4 version only. From 1.5 version onwards, we can take covariant return types. According to the child class method, return type need not to be same as the parent. That is, you can change the return types. Okay, now let's see what does this explain. So public object, this m1 method is of object type, this is returns null. Then c extends p, and this is of string type. Okay, this also returns null. So it is invalid in 1.4 version, since we are changing the return type. Here it's object and here it's string, but from 1.5 version onwards it is valid. Okay, so that is what it was trying to mean. So this is an important question that is asked, that does return type play an important role in Java during overriding or not? So until 1.4 version, we are not allowed to change the return types, but from 1.5 version onward, once we are overriding, we can change the return type as well. But there is a limitation. Let's see that as well. So in, let's say, the parent class class method return type is object, numbers, string, and double. And child class, what can be the expected child class return types? So from you can go to so from object you can go to object or string or string buffer. These are the subclasses of object. Okay, from number, this is a non-primitive, so you can go from number to number or int or float. So since this string is a primitive data type, okay, and double is also a primitive data type, so you cannot override this. Okay, so covariant return type concept is applicable only for object types, but not primitive types. That is what the limitation here. These are the non-primitive types. So covariant these can be overridden, but primitive types is not allowed. Overriding of the primitive types is not allowed. So that is what is about this third point. So next comes it into picture is parent class. If the parent class has private methods, parent class private methods not available to the child, hence overriding concept not applicable to for private method. Since method is a private, so that won't be available to the child, so there is no concept of this overriding in what we say in over and Java. Okay, so based on the requirement, we can define the exactly same private method in the child class, but it is valid, but it is not overriding. We can define, but it is not basically overriding. We are just defining this same. We can define, but it is not overriding. Okay, so the next point is we can't override final method, since it is by the name itself. Once a method is declared as final, you cannot change any of the implementation. So once if any parent has a final method, so you cannot override that method, since the implementation is declared as final, there will be no change. So let's say there's a class parent public final void m1. So if you extend the same class, let's say class child extends parent, so public void, you're changing the return type, so that is not valid in. Okay, so you are uh, overriding this method, so this is not valid. So it will throw in compile time error saying that m1 in C cannot override m1 in P. Overwritten method is final in nature. Okay, so final methods we cannot override. Okay, private methods we can override, but it's not overriding. Okay, so next point is parent class abstract method we should override in the child class to provide implementation. That is true, because abstract class has abstract methods. Okay, so abstract methods are declared as abstract because they don't have the full implementation, so we should always override abstract methods. Okay, so this is a valid case that overriding is possible in abstract method case. Okay, so we should override basically to provide the implementation to the class, since abstract methods contain the partial implementation of the method. So once the class is extending, that the next class should provide the implementation for that method. We can't we can override non-abstract method as abstract. Okay, so let's say a method is non-abstract, public this class P, public void m1, this is a non-abstract type method, and abstract class C extends P. So it is making this method as abstract. Okay, the main, what is the advantage, since when we declare a method as abstract, so what we are doing here, so we are stopping the availability of this parent method implementation to the next child class. So that means that the next child extending this class will have to provide this implementation for this method, then only it can extend, then get the properties of the higher parent. Okay, so that is what it's written here, that we can stop the availability of parent method implementation to the next level child classes. Okay, so we can stop the availability basically by declaring the non-abstract method as an abstract method. Okay, so in overriding, following modifiers won't keep any exception. Okay, so from final to non-final. Okay, synchronize native strict FP. Okay, so either you go from abstract to non-abstract, this is allowed. You go from synchronized to non-synchronized, this is allowed. Go from native to native or non-native to native, both vice versa is allowed. But final to non-final is not allowed, as we saw. But non-final to final is also allowed here. Okay, so this is something that can be asked, generally not asked, but this can be kept in mind as well. Okay, so the next point is, while overriding, we cannot reduce the scope of the access modifier, but we can increase the scope. So let's understand this. What is that? So let's say there's a class parent which has public void m1. Okay, then we have the class C extends P, child extends parent, so void m1. So I have removed public from here. Okay, I'm reducing the access modifier. I'm replacing the to default basically. So what is, it will throw in compile time error saying that m1 in C cannot override m1 in P, attempting to assign a weaker access privilege. That is, you are reducing the scope of this method. Okay, so let's see what the hierarchy is. The lowest is goes to private, then you can go to default, then default, from default you can go to protected or public. Okay, so from, if the parent class method is public, you can make it public only, you cannot change it. Okay, you cannot reduce the scope, since this is the highest scope. So from protected you can go either to protected, or you can go to increase the scope to public. From default you can either go to default or protected or public, and private method we cannot basically override, as we saw. And if we are overriding, we'll have to give the same as well, same private uh, access modifier as well. So next comes into picture, that is, if child class method throws any checked exception, compulsory the parent class method should show the same checked exception or its parent, otherwise we'll get compile time error. But there are no restriction for unchecked methods. So for checked methods, let's see what is the example here, that object is the main class, then inside object we have throwable. So inside throwable we have two bifurcation, that is exception class and then error class. So inside exception we have checked exception and unchecked exception. So overriding concept is applicable for checked exceptions. Okay, the limitations are for only for checked exception. So inside checked exception we have IO exception, SQL exception, or class not found exception. So let's see what does that mean. Let's say the parent is public void m1 throws an exception and the child is not throwing an exception, that is valid, because you should throw the same or not throws any checked exception. Compulsory parent class should throw, sorry, if the child class method throws an any checked exception, compulsory parent class method should throw the same exception or its parent otherwise. Okay, so since it is not throwing anything, so this is a valid case. So next is parent is not throwing anything, but child is throwing an parent exception, throwing an exception. This is not valid, because since parent is not throwing any exception, so you cannot do that. Okay, so let the third example is public void m1 throws exception and child throws an IO exception. Since IO exception is a child class of exception, so this is a valid case. Then the opposite case, the parent is throwing a child exception and the child class is throwing an exception, that is the parent of IO exception. So this is an invalid case. IO exception, it is also valid file not since this is the child of IO exception. So that is, these are the cases. Okay, so parent class is throwing here what, IU exception, and the child class is throwing an unchecked exception. So this is also valid since there is no limitation for unchecked exceptions. Okay. So next comes into the picture overriding with respect to static methods. So we can't override static methods as non-static, otherwise we'll get compile time error. So you cannot go from static to non-static. Okay, so you will get a compile time error. Public static void m1, this is the parent class, then this is the child class, that is public void m1. So it will throw an error, m1 in C cannot override m1 in P, overridden method is static. Okay, so static cannot be overridden. Okay, so the next thing is we can't override a non-static method as static. So if a method is non-static, so in static vice versa both, you cannot override a static to non-static, or you cannot override a non-static method to a static. Both will throw a compile time error, simple as that. Okay, then in the next point we have third point, if both parent and child class method are static, then we won't get any compile time error. It seems that we have implemented the concept of overriding here, but it is not overriding, it's method hiding basically. So class P, if we can override that static method, but static to non-static and non-static to static is not possible. But if you are overriding the static method, and that is, you are giving the same scope, that is static, and you're same, then it is valid. But this is not overriding, this is method hiding basically. Okay, so then comes into the picture what is method hiding. Method difference between method hiding and method overloading. So both parent and child class method should be static in nature. Okay, method overloading both need to be non-static as we told. For compiler is responsible for the method resolution based on reference type. Here JVM is responsible since we studied that method resolution always takes care by JVM. So in method hiding, if you are let's say do you two method, one is static, in the parent class we have a static method, in the child class we have a static method as well, that is overridden. So that is nothing but method hiding. So here compiler is responsible for the execution. Okay, and but in overloading, sorry, in overriding, JVM is responsible for the execution. So this is based on reference type, and this will be based on runtime object. So it is also known as compile time polymorphism, or late binding, or sorry, static binding or early binding, static polymorphism or early binding. And this is also this is a runtime polymorphism that we have already read. This is also known as dynamic polymorphism and late binding. Then we have class P, public static void m1 SOPLN parent. Then we have class C extends P, public static void m1 SOPLN child class. Okay, so this is what method hiding. Okay, so let's say public static void when P, parent P is equal to new parent. So what is this? Parent P is equal to new parent is parent reference parent object. So P dot m1 means based on, this is method hiding since, so the this is will be based on reference type. So what is P, what is of P, this is the reference object. So this is the, what is P is of P type, parent type. So this will execute parent method. Then child C is equal to new child. So run so what is this? This C is of type child type. So this, what will get executed? Child method will get executed. Then parent reference child object. So what is P dot m1? So P1 is type of type P, parent type. That is why parent will be printed here. Okay, so since this is method hiding, so in this case the method resolution will be taken care by compiler based on reference type. Okay, so next comes into the picture overriding with where arg method. So we can override where arg method with another where arg method only. If we are trying to override with the normal method, then we'll get, then it will become overloading but not overriding. Okay, that is obvious. So we saw also an example in overloading that public void m1 is of variable argument, that is int variable argument parent method, and child extends parent, and we have public void int of x, only one single argument. Okay, so what is this? Same method, same name, and different argument types. So it looks like overriding, but it is not. It is overloading concept. It is overloading. Okay, method with same names but different argument types. So everything will work on the basis of overloading concept only. That is, method resolution will be taken care by JVM, with compiler based on reference type. So p dot m1 of 10 will be of parent type, c dot m1 of 10 will be of child type. So child p dot m1 of 10 will be again of parent type, since it is overloading, not overriding. Okay, then we have overriding with respect to variables. This variable resolution always takes care by compiler based on reference type, irrespective of whether variable is static or non-static. So overriding concept applicable only for methods, not for variables. Okay, so let's see an example. So overriding and overloading is only applicable for methods only, not overriding. Not this variables, only for methods. Class P int x is equal to 888. Class C extends P int x is equal to 999. So parent P is equal to new parent P dot x. Since this is of parent type, this will give 888. Parent child reference child object 999. Parent reference and child object. Since this is not applicable, so this will give 888 only. So that is what is about overriding, and this is all the concept of overriding in Java. So in the next lecture we'll see about constructors, how constructors work with Java. So that is also asked in interview. So I hope the session was informative. So thank you. Let's meet in the next video. Thank you.